Now we're going to look at some basic differentiation properties or shortcuts. We're not going to be doing the definition of the derivative anymore. You've already done it, it's over. But we do have shortcuts that, based on the definition, people saw patterns, and that's what we're going to do now. Now, if we're given a function, y equals f of x, or g of x, or h of x, when you get the derivative, you need to indicate the notation that you have gotten the derivative, and that's with the prime. All of these are legal. The dy over dx I don't use. I will revisit it later for something in chapter 13, but it takes too long for me to write. Now, which one I use is dependent on how they give me the problem. If they give me y, I indicate y prime. If they give me f of x, I indicate f prime of x. If they give me g of x, then I'll do g prime of x. All of these represent the derivative of that function at or with respect to x. Now, I've got some examples here before we go and actually look at the shortcuts that I want you to see and see if you might see a pattern. Normally, I usually have people see a pattern starting at number 5. What I need you to look at is the coefficient and the exponent, and see if you see what we might be able to do with those to get this first term. If you go 4 times negative 4, that gives you negative 16, but one more thing has changed. Notice my exponent went down 1. Let's see if it happens on the next one. 2 times 7 gives me 14. Decrease power by 1. There's my 14x, or positive 14x. Now, it's understood to be a negative 3x to the first, so 1 times negative 3 is negative 3. Decrease power by 1 gives me x to the 0. And I don't need to write x to the 0 because x to the 0 is 1. Now, this is in descending order. It's understood that 8 actually has a variable here, but the variable is x to the 0. So if you go 0 times 8, it gives you 0. Some of my students like to go, it drops off, it goes away. If you have a constant, the value or your derivative of that value is going to be 0. Another way to look at it is if you graph y equals negative 7, remember that's a horizontal line, and horizontal lines have slope of 0, which is one of the things the derivative tells you about a line. Look at this next one, number 2. I've got f of x is equal to 5 times x to the first. So 1 times 5 gives me 5. Decrease power by 1, so I've got 5 times 1. Constant goes away, so my derivative, my f prime of x, is equal to 5. Well, guys, this is a linear equation, and if you know this value multiplying my x is my slope, and remember the derivative tells us the slope of a line. In this case, it's a straight line, so regardless of what point I use here, my slope's always going to be 5. The derivative of this, I've got 2 times 2 is 4, x, decrease power by 1, coefficient is 1. If you need to write that down along with the exponent, do so. 1 times negative 1 is negative 1, x to the 0. We don't write x to the 0, so I end up with negative 1. Now, the reason in the last part or the last video I had you rewrite this, it has to be in a special form. You have to have coefficient times variable raised to exponent. Once it's rewritten, then you can apply this rule, which we'll see here in just a second. But I'm going to do my f prime of x. Negative 1 times 2 gives me negative 2x. Be careful, I have to decrease this exponent by 1, so a negative 1 minus 1 gives me negative 2. Now, the book will take negative exponent answers. Normally, you change those to positive exponents. I'll take either one because of the book, but you need to remember, if you've got a negative exponent, you move it in the other direction, becomes positive. Now let's look at their shortcuts. Constant rule. If I've got a function that's equal to number e, negative 57, 1342, doesn't matter. If that function is equal to a constant, my derivative is equal to 0. Power rule. Hopefully this piece right here looks familiar. it needs to be in this form. I need to see the coefficient times x raised to exponent. So here's my derivative. My exponent times my coefficient, decrease power by 1. So if you can multiply and subtract 1, you can do this. Sum and difference rules: if you have more than one term in a function, you do the derivative individually. Actually, we did this for problem 5, actually 2 through 5. Individual terms, I do the multiplication and I subtract. This is going to be a base rule that we'll use a long time, so you need to know how to do this. Even though we now have some tools to allow us to calculate a derivative more quickly than using the definition of the derivative, don't lose sight of what the derivative tells us. It's a limit. It gives an instantaneous rate of change. It also tells us the slope of a tangent line, as well as the velocity of an object. The first two of these, instantaneous rate of change and slope of tangent line, will use the majority in this course. Every once in a while, they have some problems about velocity. And in the next video, after this one, we'll actually use or find some of these things. But they're quick now. I don't have to do the definition, so you need to be happy about that. I do have some examples. I need you to pause me. You go ahead and you find the derivative of this, and then unpause me and see if you agree with what I've got. So you better pause me now. So finding the derivative, you need to have y prime equals, I'd have 72 x to the 8th minus 49 x to the 6th plus 30 x to the 5th. That times that, what is that? Negative 54 x to the 2nd plus 8x minus 12, constant, is gone. So see if you have that. Now, usually the biggest issue I have with people in this chapter is this piece right here. You've got to know how to get it in the correct form. So the first thing you have to do is rewrite. So see if you can rewrite it. So pause me. I'm going to move the x to the 3rd up, so I'd have 2x to the negative 3 minus 6 times x to the negative 2/3 plus 7. Now you're ready. It's in the right form. You've got coefficient times variable raised to exponent. So I need you to try it. Pause me. This, if I multiply that times that, will give me a negative 6x to the negative 4. Negative 2/3 times negative 6 will give me a positive 4x to the subtract 1. That'd be negative 5/3. Constant goes away. So let's see if I get that in this box. I went ahead and changed this to positive exponents, so I need you to try it and see if you end up with what I've got under the box. X to the negative 4 goes down, x to the negative 5/3 goes down, making positive exponents. So that's all there is for this particular part. I haven't finished section, 10.5 yet. This is just getting your feet wet with finding derivatives using the shortcuts. Okay? Talk to you later. Bye-bye.